The acidity of an aqueous solution depends on the concentration of hydronium ions. The pH of a solution is defined as the negative of the logarithm to base 10 of the hydronium ion concentration in moles per liter or in moles per dm cube or molar. The formula is pH is equal to negative log hydronium ion concentration. If we want to write hydronium ion concentration, we use the formula hydronium ion concentration is equal to 10 to the power of negative pH. In pure water at 25 degrees Celsius, hydronium ion concentration is equal to hydroxide ion concentration. That is, it is 1.0 times 10 to the power of negative 7 molar. Substituting this hydronium ion concentration into the pH formula, we get pH is equal to negative log of 1.0 times 10 to the power of negative 7, which is equal to 7.00. pH is a dimensionless quantity, that is, it has no units. pOH scale is analogous to the pH scale and can be defined as the negative of the logarithm to base 10 of the hydroxide ion concentration. Thus, pOH is equal to negative log of hydroxide ion concentration. To find hydroxide ion concentration, we use the formula hydroxide ion concentration equals 10 to the power of minus pOH. 1.0 times 10 to the power of negative 7 molar is the concentration of hydroxide ion of pure water at 25 degrees Celsius. When we substitute this into the pOH formula, we get 7.00. From the definitions of pH and pOH, we get pH plus pOH is equal to 14.00. Now for some examples. Part A. Determine the pOH of a solution at 25 degrees Celsius in which the hydroxide ion concentration is 3.7 times 10 to the power of negative 5 molar. Part B. Calculate the hydroxide ion concentration in a solution at 25 degrees Celsius in which the pOH is 9.03. For Part A, we are given the hydroxide ion concentration, so we use pOH is equal to negative log of hydroxide ion concentration to calculate pOH. For Part B, we are given pOH, so we use the hydroxide ion concentration equals 10 to the power of negative pOH to calculate hydroxide ion concentration. By substituting the given values into the formulas, we get 4.43 for Part A and 9.3 times 10 to the power of negative 10 molar for Part B. Remember that the pOH scale is, in essence, the reverse of the pH scale. On the pOH scale, numbers below 7 indicate a basic solution, whereas numbers above 7 indicate an acidic solution. The pOH benchmarks in Table 16.4 in the previous slide work the same way the pH benchmarks do. In Part A, for example, a hydroxide ion concentration between 1 times 10 to the power of negative 4 molar and 1 times 10 to the power of negative 5 molar corresponds to a pOH between 4 and 5.